Bueno, ahora continuamos con el sistema hidráulico.
The Embraer uses 3 independent hydraulic systems to power the primary and secondary flight control. The landing gear, the brakes, the nose wheel steering, and the thrust reversers. All 3 systems use Skydroll and operate at a nominal pressure of 3,000 psig. The main components of the hydraulic system are 2 engine-driven pumps, 4 electric hydraulic pumps, 1 hydraulic power transfer unit, and 3 hydraulic system reservoirs. Systems 1 and 2 are powered by an engine-driven pump and backed up by an AC electrical pump. The electric hydraulic pump is used during takeoff and landing and powers the system in the event of an engine or engine-driven pump failure. A power transfer unit is installed between the 2 systems to transfer hydraulic power from System 1 to System 2 without mixing fluid between the systems. This is used for landing gear retraction and extension in the event engine-driven pump 2 is not operational. System 3 is powered by a main electric hydraulic pump and uses an auxiliary electric hydraulic pump as a backup. The hydraulic system is designed in such a way that even a failure of 2 hydraulic systems will not result in a complete loss of flight-critical functions. The following hydraulic users are powered by Hydraulic System 1, installed in the left center fuselage bay. Left outboard elevator PCU. The upper rudder PCU. Left thrust reverser. Multifunction spoiler pairs 3 and 4. Ground spoiler pair 2. Outboard brakes. And the emergency parking brake. System 2, located in the right center fuselage bay, powers the left and right inboard elevator PCUs, left and right inboard aileron PCUs, right thrust reverser, multifunction spoiler pair 5, ground spoiler pair 1, inboard brakes, nose wheel steering, speed brake, emergency parking brake, and the landing gear. Hydraulic System 3, installed in the aft fuselage, supplies right outboard elevator PCU, the lower rudder PCU, and the left and right outboard aileron PCUs. The hydraulic system is controlled using the hydraulic control panel, located in the cockpit overhead panel. The 4 electric hydraulic pumps and the power transfer unit can be selected by the flight crew using rotary-style selector knobs, whereas the firewall shutoff valve is controlled by a guarded push-type button. Electric hydraulic pumps 1, 2, 3B, and the power transfer unit use 3-position selector knobs, while electric hydraulic pump 3A uses a 2-position selector knob. Each backup electric hydraulic pump has its own rotary selector knob that can put the electric hydraulic pump or power transfer unit into auto control, off, or on. In auto mode, electric hydraulic pumps 1 and 2 turn on automatically during takeoff and landing or when primary pump pressure is lost. Electric hydraulic pump 3B only activates in auto mode when electric hydraulic pump 3A is lost and does not activate during takeoff and landing. Since electric hydraulic pump 3A is the primary power source on System 3 and is always on, its rotary selector knob has only two positions, on or off. If Engine 2 or EDP2 fails during takeoff and landing, the hydraulic system logic activates the PTU, when the PTU selector knob is in the auto position and the flaps are not set to 0. The automatic control logic for electric hydraulic pumps 1, 2, 3B, and the power transfer unit is implemented in the SPDAs. Note that there is no automatic logic associated with electric hydraulic pump 3A. It is either on or off. In case the respective SPDA goes offline, these pumps can be manually selected on. This is accomplished using a direct hardwire connection provided from the cockpit selector knobs to the integrated control circuits of each hydraulic pump. The electric hydraulic pumps 1, 2, and 3B will be in automatic mode control when their respective cockpit selector knob is placed in the auto position. With electrical power available, they will automatically be started when the following conditions are true. Electric hydraulic pumps 1 and 2 will be turned on when flaps are selected to any position greater than 0 degrees. Electric hydraulic pump 1 will be turned on when engine-driven pump 1 is not operational. Electric hydraulic pump 2 will be turned on when engine-driven pump 2 is not operational. Electric hydraulic pump 3B will be turned on when electric hydraulic pump 3A is not operational. An hydraulic fluid overheat condition may be caused by the failure of a pump compensator. This would result in a rapid rise in the temperature of the hydraulic fluid. The overheat threshold may be passed approximately 1 minute after the failure. In this event, the overheat protection is performed by temperature switches installed in System 1 and 2. They will cause automatic closing of the relevant firewall shutoff valve in the event hydraulic fluid temperature reaches 125 degrees Celsius, 257 degrees Fahrenheit. Once a switch is tripped, the firewall shutoff valve will close and stay closed. System 3 has a temperature switch installed that will cause ACMP 3A and 3B to switch off automatically in the event hydraulic fluid temperature reaches 125 degrees Celsius, 257 degrees Fahrenheit. At ram air turbine deployment, SPDA-2 commands the pump unloader valve to open, which reduces the fluid flow through ACMP-3A during pump startup. At the same time, the flow limiter valve is energized, which reduces the fluid flow to the users to 1.75 to 2 gallons per minute. This allows the ram air turbine to spin up faster to its operational speed. When the ram air turbine is spooled up and is producing power to the AC essential bus, ACMP-3A will start, and the pump unloader valve will be commanded to close, and system pressure will increase to normal pressure. The flow limiter valve will remain on as long as the ram air turbine is deployed or the ram air turbine generator is producing power. In the event of the loss of both engines, either one at a time or simultaneously, ACMP-3A will initially turn off due to the loss of the electrical power when the IDGs go offline, and the system accumulator will provide power to the flight controls on System 3 for the period while the ram air turbine deploys, spins up to operating speed, and restarts ACMP-3A. There are sufficient flight controls on System 3 to maintain control over the aircraft in all 3 axes and enable a controlled landing to be performed. In normal operation, the hydraulic system is largely automatic. Very little pilot input is required. The system architecture and control philosophy is such that it can cope with most abnormal aircraft operating conditions or hydraulic system failures without requiring pilot action. As Systems 1 and 2 have engine-driven pumps as the primary pumps, the systems will pressurize with engine start. If a switch is not in the correct position for flight, an ICUS message will be displayed, alerting the flight crew that a selector knob is not correctly set. Note that the hydraulic system allows a single engine taxi. On ground, with the selector knob in the auto position, and after starting engine number 1, releasing the parking brake automatically activates electric pump 2. Even if engine 1 is used for taxi, the electric hydraulic pump provides hydraulic power for nose wheel steering and the inboard brakes. Under extreme low temperature operating conditions, a specific hydraulic system start procedure is used. This procedure will raise the hydraulic fluid temperature to its minimum operating temperature before the aircraft is ready for flight. Once the warm-up procedures are complete and the hydraulic system parameters have reached their minimum operating limits, the aircraft is ready to taxi. When the aircraft is ready for takeoff, electric pumps 1 and 2 will come on automatically when the flaps are extended beyond 0 degrees and the airspeed is greater than 50 knots or the thrust lever angle greater than 60 degrees. Thus, the pumps are already running should an engine-driven pump or engine failure occur during takeoff, minimizing the effect of switching to the backup pump. Once takeoff is complete and the aircraft has begun to climb, the backup pumps will switch off when the flaps are stowed. The System 3 backup pump, electric hydraulic pump 3B, is not switched on during this phase as there are no high flow demands on System 3 and because electric hydraulic pump 3A is on the AC essential bus. System 3 would not be affected by the loss of an engine. During the climb, cruise, and descent flight phases, the hydraulic system uses only the primary pumps to provide the power required by the flight controls. In the landing phase of the flight, electric hydraulic pumps 1 and 2 will again switch on automatically when the flaps are extended. As during takeoff, this is to ensure that the pumps are active and warm if an engine failure or engine-driven pump failure occurs during the landing. After landing roll, the electric pumps will remain operating for 1 minute after airspeed is below 50 knots. If a hydraulic system failure occurs, the appropriate ICUS message will be displayed, prompting the pilot to open the hydraulic Synoptic page and check the hydraulic system status. The hydraulic Synoptic page presents the following information to the cockpit crew on a display page dedicated to the hydraulic system. Reservoir quantity for all 3 systems. Fluid temperature for all 3 systems. System pressure for all 3 systems. Engine pump shutoff valve position. Hydraulic pump status for both engine pumps and electric pumps. Power transfer unit status. Both analog and digital data are used for the hydraulic system Synoptic page. Analog data is used to display actual values, reservoir fluid temperature, quantity, and hydraulic system pressure, and pictorial gauges, reservoir quantity and system pressure. Digital data is used to indicate hydraulic flow paths, failed pumps, power transfer unit availability, and firewall shutoff valve position and availability. The Engine Indicating and Crew Alerting System, ICUS, is used to draw the attention of the flight crew to the existence of any aircraft system abnormality.
Bueno, listo hidráulico. Vamos a pasar a la siguiente clase.